Good morning, boys and girls. So today we are going to begin with the end in mind and we're going to think about our learning target. And at the end of today's math class, I want everyone to be able to say, I can tell whether a number is prime or composite. You may or may not know a little bit about what it means for a number to be prime or composite, but that is what we are going to find out today. First of all, let's take a look at this little math problem. Students are arranging square tables to make one larger rectangular table. If the students want to choose from the greatest number of ways to arrange the tables, should they use 12 or 13 square tables? So first of all, let's think about what they're talking about here. First of all, I'm sure you've probably been at a restaurant where they take square tables and put them together, and it ends up with one larger rectangular table. So the question wants to know if the students should use 12 or 13 square tables if they want to have the greatest number of ways to arrange the tables. So, what is this question really asking? It's really asking which number has more factors or which number can you arrange into more arrays, 12 or 13. So let's take a look at the factors of 12. So remember that 1 times 12 is 12, 2 times 6 is 12, and 3 times 4 is 12. So that's how we get those factors. And then we get to 13, the only factors it has are 1 and 13. Since 12 has more factors, there are a greater number of ways to arrange 12 tables than 13. So basically, if you had 13 tables, all you could do is just make one big long row of 13 tables, because else it wouldn't make a rectangle. Something would be out of whack. But if you had 12 tables, you could make a 1 by 12 row, or you could put them in rows of 2 and have 6 rows, or you could put them in 3 rows of 4. So you obviously have more options with the number 12. Now, the reason for this is we say that 12 is a composite number and 13 is a prime number. The only factors of 13 are 1 and itself, so that's what makes it prime. So when you're deciding whether a number is prime or composite, you ask yourself, does this number have any factors besides 1 and itself? So we're going to tell whether the number is prime or composite. So we're going to start right here with the first number, which is 11. So you got to think to yourself, is there anything times 11, anything you can multiply together to get 11 besides 1 and 11? And I don't think there is. So since there's no factors of 11 besides 1 and 11, 11 is prime. Now let's think about 73. Now 73 is a little bit harder because I have to think, first of all, I know 73 cannot be divided by 2. Do you know why? Because it's odd, and odd numbers cannot be divided by 2. But I'm thinking to myself, can 73 be divided by 3? So, if I took 73, oops, I don't like that. Let's just do a pen. If I took 73 and I divided it by 3, excuse my handwriting, it's hard to do this way. Alright, so I'm thinking, 3 goes into 7 20 times. 20 times 3 is 60. I hope I can already tell you it's not a factor because I know right now that I'm going to have 13 left over, and because 3 does not go into 13 evenly, I don't even need to finish. I know that 3 is not a factor. So I'm thinking, is 4 a factor? So let's try this with 4. Okay, so I can't do 3. I can't do 20. I have to do 10. All right, so 10 times 4 is 40, and 73 minus 40 is 33. I know that nothing times 4 equals 33, so 4 is not a factor either. I know 5 is not a factor because it would end in a 0 or 5. So I'm pretty sure that since I can't think of anything that equals this number besides 1 and 73, that this number must also be prime. Yep. All right, let's look at 69. Now, if I took 69 and I thought of it as 60 plus 9, I know that 60 is divisible by 3 because that's 20. 20 times 3, 30 equals 60. And I know 9 is divisible by 3. Therefore, 69 must have a factor of 3. And if it has a factor of 3, then it must be composite. All right, 42. Oh, this one's easy. Easy, 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 because first of all, I notice that this number is even. And if I have an even number, then I know right away that it cannot be prime because all even numbers have a factor of 2. So 42 is composite. When you come see me today, we're going to be talking more about whether we can tell whether a number is prime or composite.